EAA's webinars are made possible through the generous support of Aircraft Spruce and Specialty, serving home builders and EAA members since 1965. Tonight's presentation. So, you want to build a jet? And our presenter, Lance Hooley. Lance is a former enlisted member of the Air Force. He's also building a long, easy trainer. He wants to do checkouts for other people that want to learn to get transitioned over to Canard-type airplanes. Very cool. Flies for a major airline based in Orlando, keeps the jet easy. He's talking to us tonight about at the Kissimmee Airport, a member of EAA. Lance, thanks so much for sharing this. I'm sure is going to be a very interesting story about your project with us tonight. I'm going to turn control of the presentation over to you.
All right, I appreciate it. A lot of this presentation is going to be all about the jet, how in particular the jet engine, how did we get it in there? But I've got to give you a little bit of background information about the airplane of how we even got to putting the jet engine in it. This isn't my first airplane. It's number 4, to be honest. In the past, I built the Rutan Very Easy and the Quickie. The Very Easy took me 2 years to build. I finished it in 1981. The Quickie I did in the mid-'80s. That took 6 months. It was rather easy to build, especially after you've built some of the other designs. The Dan Wren 107-1 design, true composite airplane, all wood wing, chromoly steel fuselage. Took 2 years to build it. It's quite a crotch rocket. Very, very easy tail dragger to fly, an incredibly responsive, unlimited category airplane. And then I started on the jet. When I started on the jet, I actually wanted to build a long easy. That was my original intent, just a high-powered engine long easy. But to get there, between the Quickie and the one design, I actually helped a gentleman. He taught me fabric work. His name is Ray Williams in Tennessee. In working with him, I rebuilt several pits, Stearmans, Skybolts, Stinson 108. So I got my feet wet, if you will, working with him doing the fabric work. And then I got a job with a commuter airline, moved to Florida. I started working for Jim Kimball Enterprises in Zellwood, Florida. The commuter airline pay is just as bad as you hear. Consequently, I was working with them in order to be able to eat. But working with them, I learned a lot of the incredibly finer points, because most of the stuff the Kimballs turn out is showroom quality workmanship, and they expect that out of you is to be a craftsman in order to build it. Back up to the Jet Easy. It took me 13 years to build that one. The reason is I didn't work on it for 2 years. And then a lot of the stuff on the jet, we prototyped. So when you prototype something, you end up building something 2 or 3 times and don't like the part, or the first time you build it and decide you can do better. So you build a second one, and you decide, oh, I can do better than that, and you build a third one. You'll see that time and again throughout the entire presentation here. One of the points I want to bring out is just because you have ratings, I've been flying since 1974 and professionally since '81. I have all the ratings up through ATP. The difference is I've been flying constantly, even through the build process. Building this airplane has been a part-time job, if you will. Working on it on weekends, sometimes after work, sometimes before work. So I never quit flying. So when it came time to fly the airplane, I was current, and I was flying jets at the time. So, and still involved in general aviation stuff. So I had my feet wet in both areas. Now I also have a commercial balloon rating, and I'm going to get the AMPs, like I said, simply because I want it. Now back to just because you have the rating, part of what I want to point out is a lot of people spend 10, 15 years building an airplane. They don't fly in the meantime, so their currency is kind of lapse. You have to have a little bit of common sense there. I have a commercial balloon rating, but I haven't flown balloons in a long time. That used to be my balloon, what you're looking at now. So to go out and fly, even just fly a balloon just for fun right now by myself would be not wise. So just because you have a rating to me doesn't really mean a lot. So you can do this stuff without the ratings and be just as competent, in my opinion, as someone that has all the different ratings in order to do this. Back when I started, if you'd have told me then that this is what I'd be flying now, that's a hard concept to get your mind wrapped around. One, because it takes so long to get there. While you're in that tunnel, we have a joke out at the hangar where the airplane is now, that the light at the end of the tunnel, yeah, that's the freight train coming at you. So it's hard sometimes to see the light at the end of the tunnel, especially when you keep building and building and building, and you can't seem to make progress. Sometimes you can work on the airplane for 5, 6, 7 hours, step back, and you can't see anything that you've done. It's like, what did I do? I've been here all day. So that was a constant thing throughout this entire project. And you're going to have problems when you undertake something this complex. Just accept it. Don't get upset about them. Just figure out how to overcome the problem. Well, back to, I wanted to build a long easy. So we're back to there when this whole thing started. And I'm not very smart. I admit that, but I'm smart enough to know I'm not very smart. That makes a little bit of a difference. So consequently, I surround myself with people that are smarter than me, which, when you're not very smart, it's pretty easy to do. But in this case, I had stumbled across an article in the EAA Sport Aviation about a guy by the name of Robert Harris. At the time, it was the Easy Hangar, and it morphed into the Easy Jets, and now they're the Jet guys. So I called Robert and asked him, could I come over and talk to him about this? And in hindsight, I know what he was thinking. Here's another wannabe. So he agreed. It was kind of hard to get the appointment because of my schedule. I was flying for commuter and Robert's schedule. And finally I got over to him. It's a 2-hour drive to go to him, and spent about an hour talking to him. And one of the things he brought up from the get-go was, why build the airplane, even a long easy, with 1970s technology, which is how the long easy was designed. It was designed in the 70s. We have, and this is 2001 when I was talking to Robert, why not build it with what we know now instead of how the plans were drawn up? So that kind of bothered me at first, to be honest, because that's getting away from the plans. Rutan's the guru. He's the expert. Well, why do I want to change it? Robert took the time to explain a lot of stuff. I actually took the time. And this kind of, I see it now with people calling Robert all the time, and they'll spend an hour on the phone with him, and they never do anything. So I see this all the time. Or people will call and ask him, how would you do this? And he tells them, and they say, well, I'm going to do this. And I think, well, why'd you even call him? So one of the first things I did was surround myself with somebody that's a lot smarter than me about this process, about building this airplane. And that was Robert. And I moved to Florida. This is in Florida. The center picture. Always remember, airplanes are fun. Airplanes are fun. Airplanes are fun. This is all wood and foam dust from the first fuselage tub that I built. It's upside down. I'm trying to get the rounded shape that it's supposed to have. Over the next little period of time, I built a lot of parts rather fast, and that was strictly because of my past experience with building the Very Easy and the Quickie. On the bottom left, those are the actual bulkheads for the first fuselage. And then the top left is actually the center section spar that I used. It's my design too, by the way. This entire airplane, as much as I would like to say this is Rutan's credit, I can't. And that's for a couple of reasons. One, if I run into problems, it's not Bert Rutan, it's me. So there's no blame on him. I would very much like to have his blessing with this airplane, but I've not even talked to him about it. So I don't know what he thinks of it or otherwise. It looks like a long easy. It is not. I will tell you that right now. When I talked to Robert for that hour, I told him I'm going to put a big engine in it, an IO 360. And he said, well, that's going to push the speed up faster than a VNE for the long easy. So you got to make this change, that change, this change. Okay, so I wrote all those things down, and as I was building, incorporated those changes. Now, because of all those changes, it is not a long easy by many stretches of the thing. Even at this stage, it is not a long easy because we changed the wing, the structure of the wing, the internal structure, the canard. At this point, it's a stock fuselage. So I can't call it a long easy as much as I would like to. And give credit to Bert. Bert is the inspiration for this airplane, make no doubt about it. It looks too much like a long easy, but I'll get into later why it really isn't a long easy. 2 years go by, I call Robert again. Hey, I've got these parts. I had the wings built, the canard built, center section spars built, the fuselage. In a tub stage, which means just the sides and the bottom, the bulkheads are in it. And then Robert said, he was a little bit impressed with how fast I was being surprised is what he was. I wouldn't say impressed, but he was very surprised with how fast I was building these components, because a lot of people will talk about building the airplane or doing this and doing that, and they don't do it. Well, he saw that I was actually following through with it. So he suggested making the fuselage wider for a real person. Bert he's a tall guy, but he's not that big. So make it for a real person, make it wider. So make it 4 inches wider, right down the middle. And then make it longer so a real person can sit in the back seat. If you sat in the back seat of a long easy, it's a little cramped. I'm only 5'9", and I'm kind of cramped in the back seat. My wife is taller than 5'9", and she would be really cramped sitting in the back seat of it. So, okay, yeah, make it longer. So make it 6 inches longer. Change the front seat back so it's not as reclined. It's actually more comfortable. So we moved it 1.5 inches forward at the top as compared to a stock long easy. Didn't move the bottom forward. If you do that, then it makes it too short, and you can't. The rudder pedals are cramped and all that. So just the top of it, of the front seat, is moved forward 1.5 inches, and then make the fuselage stronger. Because I could have put the IO 360 on it, the stock long easy is designed for 115 horse engine. I'm going to strap the IO 360 on it, pumping out somewhere around 200 horsepower. So I need to make some changes for the torsional loads that are going to incur on the fuselage. So we did that. And then, oh yeah, nobody ever lands off airport, right? So add puncture resistance for an off-field landing. So there's actually applied Kevlar inside the fuselage. Well, that's on the second fuselage. Yeah, did you catch that? I built the first one. Then Robert said, make all these changes, longer, wider, stronger. Wait. In order to do all that, I'm going to have to cut fuselage into 4 pieces. It's quicker for me to build an entire new fuselage with this in mind than to try to fix the one I had. So I did. I gave away the first tub, literally gave it away. I have no idea where it is now. The guy that took it hasn't contacted me or otherwise. So, but anyway, built the second tub. Along with the increase in horsepower, there's all kinds of other changes that you have to make with engine mounts and that kind of stuff, and we'll get to that. So on the left is the new fuselage bottom. Now, if you'll notice, I think my pointer, you can see my pointer here, that line is where a normal fuselage edge would be from here over in a long easy. So I added this much to it, to the width of the fuselage. So it's 4 inches, pretty much right down the middle. And you can see.
Hey, Lance, this is Tim. I just wanted to let you know that I didn't see your pointer on there. Were you using your mouse?
Yes, sir.
Oh.
Yep, using a mouse. No pointer? Okay.
Okay. Yeah, no, I didn't see your mouse. Yeah, no problem.
Sorry. Okay. So on the picture on the left, you see the lines down the right side of the foam. That's the outside of the fuselage on the bottom. There's a change in color of the foam about the middle. That's how wide a normal long easy would be from there to the left. So it's wider. And then the picture on the right, you can see that, yeah, it's wider than a stock long easy. And we also changed the wood at the top is the longerons. This is where the fuselage is actually sitting upside down. And the wood is also in a different position for the top longerons, which also gives you more shoulder room. So besides the fuselage being 4 inches wider, we moved where the top longerons were to incorporate them in the sides of the foam, and that gives you another 1.5 inches at the shoulders. Makes a big difference. This is the fuselage upside down. Top left picture is fuselage upside down. And one of the changes we had to make because of the bigger engine and prop clearance is I wanted it to sit taller, and also I wanted it to sit a little higher and sit on all 3 gear. You know, always see long easies with the nose down. That's for to keep the thing on the ground with nobody in it. A stock long easy only has about 3 pounds of pressure on the nose gear if the nose gear is fully extended. That's why guys always retract the nose and put the nose down so it won't flip over on its back. Well, we moved the gear 1 inch aft. And by doing that, changes the center of gravity when it's on the ground. And consequently, I could leave it sitting up on all 3 gear and it won't flip over. Also, I wanted it to sit a little bit taller. So that's why the extrusions are also bigger, is because I made it sit taller. The bottom right picture is what a real tub stage is. The gear's mounted into fuselage, wings are on it, center section's permanently mounted, the canard's just sitting on it. So that's what it looks like sitting in a driveway. And yeah, you get some strange looks from the neighbors when they drive by. Then Robert drops the big bomb. In the middle of all this, once he sees, yep, I can actually do all this building, says, why not put a jet engine on it? I go, wait, what? So Robert had already built the Cozy Jet and flown it and proven the engine. The engine itself is a GE T58, General Electric, and it was originally designed back in I think it was the 60s as a pure jet engine. But the contract fell through, so they GE ended up putting a PTU section on the back of it. That's the right side of the picture. The very right side is what's called a power takeoff unit, a PTU unit. That's where the transmission is, and it goes to for a helicopter for the drive shafts and that kind of stuff. Obviously, we don't need that. So we actually take the PTU section off. Taking that PTU section off, you also have to modify the back of the engine. And I have some pictures further in that I can show you some of those modifications. So we actually take it from a gas producer in order to drive that shaft back to its original intent as a pure jet engine. Now, one of the reasons Robert did this is because he says builders usually have one of 3 things. They either have the time to build something, or they have the money to build something, or they have the ability to build something. Most don't have all 3. And by saying that, I'm not trying to insult anybody. I was there, even building this. I didn't have the money to do all this stuff at one time, which is one of the reasons why I wanted to build a Long Easy. I didn't have the money to go get some of these kits and build the airplane. So the Long Easy, you could pay for or the Jet Easy. You could build things and pay for them as you go, because it's entirely scratch built from plans. So that enabled me to have the money, and I had the time because I was working for the airline. I'd fly. Sometimes you end up 2 or 3 days off at a time, sometimes a week off at a time. Sometimes you go for 2 weeks, you don't even look at the airplane. And fortunately for me, I had the ability because of my past experience in building other airplanes. So that's how I ended up going with that, having the time and the ability and the money It was a combination of working towards all three. The engine, how did I get it? I get that question a little bit. The Cinderella storybook story that you always hear about, eBay, you know, people get the fantastic deal on eBay. That's where this engine came from. It was on eBay for $12,000. I called the guy, offered him $10,000, take it off eBay and sell it to me. He did. What you see it sitting in here is the can that it was in. You can't really tell, but well, you can see in the top left of the engine, there's a yellow and green tag hanging off of it. Most of the components on this engine were 0 time. They had been removed and replaced by the Navy. So this is a 0 time engine by the Navy. So I got very fortunate by getting a 0 time jet engine for, by the time I had shipping, I had $11,000 in the engine. Those engines now run anywhere from $38,000 to $40,000 for the same engine. I just got really, really lucky to get this engine at that price. I've not found any at that price, at that condition, anywhere close to that condition since. Some of the changes that you make. These are just some of the changes that happen. Now, a rule in airplanes, building an airplane. You change one thing, you're going to change 6 others. I'd say that's a bit conservative. The engine mount attachment points, they're the same place as you would find on a long easy, but the attachments are a lot stronger. It has to have an intake plenum system in order to feed the engine. Now, I'll tell you anything about this airplane you want to know. There are no secrets in building this airplane except one. And I'll tell you the reason. The intake system, plenum system. I'll tell you about the intakes, but I won't tell you about the plenum. I'll show you pictures of it. You can see it when I pull the cowling off, did it at Oshkosh. But to explain it, and there's internal sections to it that you can't see. That plenum is critical to the engine running. It's a turbine engine, right? It's got a big fan at the front of the turbine. Air has to hit that fan at the exact correct angle in order to feed that engine. If you make the intakes too small, you're going to starve the engine. You never get the power that you need. You make them too big, you can end up with a thing we call tunnel rumble. The air is going to rumble in there. It actually builds up an air dam in front of the intakes. It'll actually slow you down. So that is really the only secret. Now, if you want Robert to build you one, he can build one. He would be more than happy to build them for you. But to let you do it, it's just, there's too much voodoo involved in doing it, and I cannot overemphasize how critical those plenums are. The engine support systems, we had to come up with all of that stuff. Oil system, fuel. We had fuel feeding problems that we ended up having to figure out. The logic did not work, but we ended up having to figure out why we were having the fuel feeding problem and fixed it. The oil tank fabrication. The oil tank has to be in a certain position on turbine engine because if it's the oil tank sits too high, it actually backfeeds through the engine, and you'll end up with a puddle of oil under the engine. It is a round engine, right? So, but it's not that kind of round engine. One of the modifications made to the wings is the ailerons and elevators are made out of carbon fiber. One of the hardest parts about a long, easy airframe in general is getting the control surfaces to balance. We had a VNE speed, never exceed speed of this airframe is 250 knots indicated, 310 knots true, okay? Those are my limits. I won't go past that. Have I been past that? Yeah, I won't tell you how far. It was exciting. But we made them out of carbon to make them easier to balance. Center section spars, heavily modified. Okay, so to be able to withstand the kind of loads that we're putting on it. The blended winglets, those are, if you don't do more than 150 knots, you're really not gaining anything out of blended winglets other than cool factor. They look cool. So the blended winglets only probably saved me maybe a gallon or two an hour. So I did them because I could. They really don't help that much because I'm not that much faster to really help, but it was a challenge. It was something I wanted to do, so we figured it out. The aerodynamics at the base of the winglet, the winglet there where the blend is, that's kind of critical. And then it gets into some how do you attach those winglets, because if you look at a Defiant or a Long Easy or something like that, the attachment of the winglet to the main wing is rather extensive. I got a blended winglet, so none of those designs will work. So we actually had to design our own attachment system, and I'll show you pictures of that in a little bit. Rudder actuation system. I don't have a 90-degree angle down there, so how do you get the cable up there and have hidden bell horns and make the rudder work? Because the rudder's in the winglets on this airplane, and they both go out. They don't go bidirectional like a regular rudder. So how do you do that? The gear attachment, we already touched on that. It sits a lot lower and it's a lot heavier. The airplane was going to be heavier at this point when you were putting a jet engine on it. So I was going to be carrying a lot more fuel. So that meant the gear attachment had to be even stronger. Electrical system is integrated 12 and 24 volts through this airplane. And most of the engines 24 volt. A lot of the stuff in the airplane's 12 volt. Yeah. The aileron control system had to be modified because the fuselage is wider and still has to curve around and go back through the firewall for the ailerons. So that created some headaches and how to get that system back there and make it nice and tight. The airplane is what we call airframe limited. The engine can push this airplane faster than the airfoils can, or the airframe can take. So creates a little bit of a predicament. You can overspeed the airframe. So that's why I say it's 250 indicated, 310 true is your max speed. I'm not trying to insult anybody, but aeronautics, as you climb up in altitude, your true airspeed increases. Most people know that, okay? So if you hold, say, 200 knots during the climb, and you keep climbing up, your true airspeed is increasing the whole time you're holding 200 knots. So you can watch your true airspeed increase. Well, when it hits 310, that's as fast as I can go. So you actually have to pull the nose up. So as you get higher, your climb rate actually increases. Now, that's not particular to this airplane. I fly an Airbus for a living. Same thing happens in the Airbus. It's a dog above 25 to about 32,000. Hit 32,000, it's reached its max true airspeed, and all of a sudden the climb rate increases. That's pretty standard with this kind of airplane. Top left picture is the fuel header tank. I'll explain why it's all those nice swirly colors, but that's one of the things I had to fabricate, which ended up being a failure, and that's fine. We know why now, and I'll tell you why in just a little bit. It was an experiment. The reason it's red like that's experiment with my foray into painting, and I'll get into more of that later. But it's clear coated and all that. It's not even in the airplane now, but that's okay. The bottom left picture on the top portion, top left side of the bottom left picture, that's the oil header tank. Below it to the right, that's the fuel header tank. That's where it used to live. Okay, this obviously is during construction. You see the wires hanging all over the place, trying to get everything set up. And the plenums are not in place right now. If you look at the picture on the top right, you can see the plenums in the bare bones fiberglass. They go through an opening in the cowling. And once again, the engine's on the bottom right. Like I said, we took the PTU section off of it. You'll see a picture of that in a bit. The cowling, top left picture, is all carbon fiber. It's about 5 feet long. And yep, goes all the way around the airplane, or all the way around the engine. It's very, very light. It's bulky. One person can pick it up, walk away with it. It's not heavy at all. Probably doesn't weigh 15 pounds, the whole thing. All set up, clear, painted, primed, everything. It's carbon fiber. It's pretty light. The top right picture on the right side, about the middle, that's the back of the right intake. That's what the plenum attaches to. It goes from there up through the center of the picture, through that V opening to the engine. That curve is critical. That's why I say in the plenums, the bottom left, you could see the same fuselage upside down, and that's the same curve that it's going through to go to the intake. Now, in this picture, the plenum, in the bottom left picture, the plenum is not complete. The center part of it is not done. And to be honest, that's where most of the voodoo in the thing occurs. The bottom right picture is a front-on shot of one of the intakes. Interesting thing, what we did in the intake, you have a formula, and Robert knew the formula off the top of his head, but we confirmed it in a couple aerodynamic books. That intake has to be, like I said, of the correct size. If it's too big, you get tunnel rumble. Too small, the engine won't work right. It can't suck enough air. You lose power. So 4 of us sat at the table with that formula and figured out how big those intakes need to be in square inches for each side. Now, give you an idea how much air this engine will pull at full power. An Olympic-sized swimming pool full of air per minute. That's how much air has to go through here. So if you're ever around the jet, stick your hand up in there. It won't bite. I might, but it won't. And just inside the lip of that intake, you'll feel a ridge, and it drops down. It gets narrower about 2 inches in. It's Coke bottle effect. The air is sucked in. As soon as it gets past that lip, it actually accelerates to go through that intake. We had the airplane on a trailer to move it from Florida to Tennessee and ended up pulling it through a whole bunch of rain. And the plenums were not on it, just had the intakes on it and the cowling on the back. Interesting thing we found is we were worried about the aerodynamics of that. Were we going to have laminar flow? Was it going to work right? We didn't know. Gear leg fairings were on it. We did not know if everything was set up exactly like it needed to be. The road dirt in the water was straight parallel lines all the way through it. It was almost perfect on the gear legs and the intake. So we had kind of a poor man wind tunnel on how to get it right. Top left picture, that's how you start with the plenums, figuring out where it needs to be, and the engine mount also. Put the engine where you want it, you build the engine mount to it. We ended up getting the engine, because of the intakes, where the intakes were on the bottom of the wing, the bottom of the strake, the engine had to be a little bit further aft than we really wanted it. The bottom left picture shows another picture of the plenums. So the engine's further back than we wanted. That came back to bite us down the road when we did a weight and balance on it and found out that it's tail heavy. So, and that's kind of a little bit of a common problem with the long, easy type design anyways, being just a tad bit tail heavy. And the bottom right picture is the engine mount built, and the plenums had already been done, but that shows you just how far aft the engine actually has to sit in order to make all those corners to feed the front fan the way it needs to be fed. Top right picture shows you how busy it can get real quick. Turbine engines are kind of cool. They're really, really, really easy to operate. Once it's running, it's running. Not much to it. Push the power lever up, no mixture, no nothing. Just go. So that's kind of cool. But the supporting stuff to make it do that can sometimes get a bit daunting. What you're looking at primarily there, that bell horn that you see in about the 3/4 of the way on the right side of the picture, that's actually how you control the power. That's connected to the fuel control. So it goes from the cockpit through that cable down to that bell horn, and that's the power control arm on the fuel control. All of that had to be designed. So you notice that, okay, I'm moving the power lever, but I've got to move the control arm in the opposite direction. So I had to figure out all that geometry. The voodoo I was talking about on the left picture is, you look at that where I'm pointing, that's actually a cone inside the tailpipe. Now, on the top right picture is the tailpipe, okay? $7,000 for that piece of metal. It's a Hastelloy is what it's made out of. What's critical is if you look past my finger, you see those, what looks like on the right side, on the left picture, past my finger, You see, it looks like blades in there. Those are actually fixed. It's called a stator. All right, it's a fixed blade. See how it's got a cutout in it? That's how you take it from a gas producer back to a straight jet engine. Okay, that's one thing. And the second thing is it has to have that tail cone. If you look past my finger also, you see it looks like veins sticking out from that cone. There's 5 of them, okay? Those are critical also to hold that cone in place. Between the cone, the diameter of that pipe, and the length of the pipe will determine your exhaust gas temperature, which also is going to determine how much fuel you can put in the engine. Okay, so it's EGT, exhaust gas temperature, is what you limit a jet engine with. With this kind of jet engine, this is a turbo jet, a straight tube like a Lear 23, same thing. On the bottom right picture, if you look at the left side, you can see those stators where the cutouts are. Okay, that's with the tailpipe off of it. Okay, this is some of the modifications you have to make to a turboprop engine that was a pure jet engine. Now, could you take a PT6 and do this? I don't know. That's, to be honest, way over my head. I don't know. I've thought of it, but I don't know if you could do that. And then how would you get the exhaust out? How do you get the thrust? Because this is a real thruster engine now. It's not a turboprop. So that's how you end up with it. And that tailpipe is very, very important. I mean, if you cut an 1/8 inch off that tailpipe, it can lower your EGT a substantial amount. Now, lowering EGT isn't always a good thing. You lower EGT, you're also not getting as much thrust as you want. Now, jet engines are designed or are measured in pounds of thrust, whereas like an IO360's horsepower. So there's no real direct correlation with horsepower and thrust. If you wanted to put a number on it, call this thing about an 800 horsepower engine. It's somewhere in there. It's phenomenal. Okay, so the Voodoo is the intake, and that part right there. Did we build that tailpipe, or I build that tailpipe? Nope. That metal's way too expensive to me even want to handle it. I mean, when I pull the tailpipe off, I get a second person standing there to catch it in case I drop it, because it weighs about 30 pounds. It's not exactly light, but it's incredibly well built, precision piece of machinery. So anyway, top left picture, I've been upside down in an airplane off the runway. Robert's been upside down. So getting upside down is kind of an important thing with you. And Mike Melville, one of Rutan's test pilots, wasn't happy with the, quote, rollover structure of a long easy, and changed the rollover structure to make it true rollover. It wasn't really a rollover structure in a long easy, it's a headrest. It didn't have any real strength to it to support an airplane if it got upside down. So here, a lot of the black stuff you see on the top left picture, that's duct tape. It's just to protect the surface. But built a true rollover structure, reinforced the seat back. This is an afterthought, by the way. I didn't build it with this in mind. This is something that decided, you know, my head's softer than it used to be. So I kind of would like more protection. So we integrated and welded up that rollover structure. Now it looks like that now, but I built a snarky little cover to go over everything so you don't see all that nice ugly metal hanging out there. And also the fiberglass is easier on your head and your hands when you hit it versus the metal. So, but it is a true integrated rollover structure, probably overbuilt, as is the story with most of this airplane. I overbuilt it. So I'm not a structural engineer. I did not go to college. I'm just all self-taught. So this is all, a lot of it, best guess. And I erred on the side of what's really, really good. Once again, surround yourself with people that are a lot smarter than you. Listen to what they have to say. Everybody I talk to, they'll give you their advice. They'll tell you what they think. The problem is, are you going to listen to the people that you really respect with the information? The top right picture is, once again, the fuel header tank in the middle. That gray thing, this side of it, is a fuel strainer, fuel filter. That's the primary fuel filter for the airplane. That's where it lives today. Off to the right of the fuel filter is a fuel flow meter. Now, you notice it's a black one. Most of you guys probably use a red one for it's for a lower fuel flow. I can go up to 150 gallons an hour fuel flow through this, and I've seen 101 gallon per hour fuel flow on takeoff on a hot day, and that's pretty. I'll get into that in a little bit. Don't freak out just yet, but yeah, you could suck down some dinosaurs real quick if you want to. The fuel flow meter did not work there though. That's why I'm telling you this. Too much turbulence coming out of the fuel filter, so I could never really get an accurate or steady reading as to how much fuel I was actually pulling out of the thing. So I ended up changing where the fuel flow meter lives. The bottom left picture is what I ended up with after pulling out the fuel header tank. That big silver thing in the middle is a fuel pump. We put it in there. I put it in there because it makes me feel better. This is a pure gravity feed system. I've yet, since we pulled the fuel header tank out, I've yet to have a fuel feeding problem. With the fuel header tank in there, I could empty the fuel header tank faster than it could fill itself, and it was starving the engine. And it would actually chug, and it'd be the equivalent of a piston engine missing and cutting out due to fuel starvation. The jet engine was doing the same thing. It chugs when it does that. It's not pretty. So I ended up pulling the fuel header tank out, and all of a sudden all the fuel flow problems went away. It can feed off both fuel tanks. Now it's in the strakes. The main fuel tanks are in the strakes, just like a Long Easy, except my strakes are a lot bigger. They're over twice the size of a Long Easy. I hold 107 gallons between the two strakes. Okay, so that fuel pump though makes me feel better for takeoff and landing at very high power settings, pulling fuel. So that fuel pump will pump 140 gallons an hour. The thing about the fuel control is you can cram as much fuel to it as you want. It doesn't care. It'll only use what it wants. So even though I'm slamming 140 gallons, it's unregulated, that fuel pump. Even though I'm slamming 140 gallons an hour at it, it will only use what it needs. So I have positive fuel pressure to my fuel control 100% of the time with that pump. So that's kind of cheap insurance for that, just to make sure that I don't have a problem. Because, and one of the reasons we did that is Robert was building a jet. It's finished now. It's John Albritton's jet. It's the one that if you go to the jetguys.co website, you can see John Albritton's jet. It's got the one with the twin tails. Kind of looks like an F-15, F-18 combination. His has a fuel feeding problem at 100%. It doesn't like it. It's almost an identical fuel system. So until we figure out what's going on there, we both decided we're going to run these pumps just because it's really, really cheap insurance. So sometimes in the building of an airplane, even though it's not what you want, sometimes it's the most prudent thing to do, just on to err on the side of safety. Back on those winglets that I was telling you about, blended winglets, the picture on the far left, okay? That's looking down the winglet at the wing. I know it's kind of hard to grasp what I'm doing there. It's a weird looking picture, but the foam is the actual winglet, right? What we did is, like I said, we had to incorporate the wing to the winglet. How do we do that? We extended the spar of the wing full length of the winglet. It's a C-section spar, it's shaped like a C. So we scarfed it onto the wing joint and took it all the way up to the tip. Now, Long Easies, Very Easies, Defiance, all of them, they have spar cap material. We extended that also from the wing to the winglet. The math we did says that we can do about 170, 190 knots at a 90-degree angle, and that winglet will stay there. I wouldn't want to try it. but it's nice to know that it'll stay there. And yes, all the way up to max speed, I've had it. They just sit there. They don't care, right? The center picture shows you what the blended winglet looks like in micro, right? That's both winglets, one wing sitting on top of the other. The wing on the right is the right wing, and you're looking at the back of the other winglet. Top right picture is the wing before any micro, and that's the aileron in carbon fiber. It's a little snarky trick I came up with on how to jig the aileron in place before you drill any of the hinges for it. So you get an exact fit. Worked out really, really, really well. It's just paint sticks to hold the aileron exactly in place. The bottom right picture is Robert and I in our heavier days. Both of us are about 35 pounds, Robert's 40 pounds lighter. I'm about 35 pounds lighter than what you see there. The wings are upside down. We had just glassed the outside of the winglets. And I'm putting on peel ply, which we use to wick up excess epoxy and make the layup a little bit flatter and get it ready for the next step. There's quite a bit of humor involved in building this airplane too. Top left and two left wings don't work. Well, I was trying to get caught up on some of the building, so I asked Robert, would he hot wire out a couple of winglets for me? So he did. So he sent me the winglets. I had them all laid out, ready to start glassing. And I noticed that they were both identical. And I started looking at the airfoils and stood them up on ends, pulled them out of the jigs, and realized he sent me two left winglets. That doesn't work. So, it can be a bit humorous, and even Robert is an expert with Canard airplanes and the winglets and hot wiring and all that. Everybody makes mistakes. So I ended up with two left winglets. And then the left gear, the top right one and the bottom right one, those two kind of go together. Everybody wants a stiffer gear. Yeah, okay, this thing, with all the fuel it's going to carry, I'm banging up on a 3,500 pound max gross weight. So I had to make the gear a lot stiffer than you would find in a long easy. If you don't believe me, come up to the gear and I'll show you the difference. It's almost twice as thick as a long easy gear. It's really the thickness of a Defiant gear. It really looks like a Defiant gear. And then, like I said, we made it taller. The airplane sits about a foot taller, stands a foot taller than a regular long easy. A long easy top longeron comes up to about my belt. This top longeron, I can drape my armpit over. So it's almost a foot taller. The thing is, where that comes into play is when you fall out of it. Because in the building of it, you're going to fall out. No doubt about it. And the first time I fell out of it, I did a 1.5 off the side of it. Saw the ground, went, okay, this is going to hurt. Nope, not yet. Got to see the ground again, then hit the ground. So fortunately for me, the garage floor broke my fall, so that was a good thing. And yes, in the tandem airplanes, the bottom left one, yeah, you can lock yourself in the back seat. Did it a couple times. So when you're working on airplanes in this day and age, I highly suggest you keep a cell phone with you, because you could do what I call, lock yourself in the back seat. You need help, that, or you hope you have a good book till somebody comes looking for you. And these airplanes get pretty warm when you're sitting in them in the summertime. It's 90 degrees outside in unair conditioned garage, and 85% humidity. You break out in a pretty good sweat pretty quick. So keep your cell phone with you. And also you could do what I did with another thing, is I call it quarter blood technique. When you whack yourself with a die grinder, an industrial die grinder, and it hits you about 3,000 times before you can get your finger out of the way. I call that a quarter blood technique. So anyway, the left picture is when I had the airplane in Florida and I need to flip it over. Okay. If you notice the rollover thing, I'm pointing this out because this might be helpful to you guys if you ever need to flip an airplane over. That's just kind of a half wheel design, right? 2x4s at the bottom, hold it in position. Okay. What's so neat about it? All right, glad you asked. You notice that the cutouts where this drake is off center. Robert's barely leaning against it. Those ropes are just in case. He's barely leaning. It's almost perfectly balanced. So this little technique of flipping the airplane over worked out really, really well. On the top right, a few minutes later, okay, it's flipped over. The bottom right. Top right picture, I was putting that canopy on, and guys were pulling up. And one of the funniest stories is guys were pulling up in front of it, asking, you know, what is it and all this? Is that a jet and all this? One of the guys is Cadillac Escalade. 7 people in the Cadillac Escalade. The front right window comes down. The guy yells out, "Is that a jet?" And Robert goes, "Yep, sure is. It's okay though. Lance's wife there used to be a Playboy bunny on their DC-9. Still has the rabbit tail." That story got around the neighborhood. It really did. True story. In building the airplane, if you're 90% done, 90% to go. You know, you have a lot of accomplishment there sitting in front of you, but there's still a lot to do. It seems like it's never ending, and this is where that don't stop. Keep putting one foot in front of the other. Just keep going. Pick a job for the day and finish that job. Don't go off on a tangent. Just keep going. This comes into play when you're doing the finish work. Sanding, it's a fiberglass airplane, moldless composite construction. All of Rutan's airplanes. That means there's a lot of fill and sand, fill and sand, fill and sand, fill and sand, fill and sand. Okay. Then you end up having to paint it. It's gray. Okay. That's not paint that you see on the airplane. When you see pictures of it, you see the airplane. That's primer. It's K36 primer. K36 is tintable. All right. That's an experiment. I wanted to get the winglets painted where it looks like it has American flag over it. I got quotes to do that, anywhere from $18,000 to $23,000. I'm going, this can't be rocket science. That's how I got sidetracked into the painting of the airplane. Took airbrush lessons. You know, you could take airbrush lessons. I did not know that. It's a week course. And I have them out in Vegas and I have them in Orlando. And learn how to airbrush. That got me into mixing paints. Well, can I mix primer? So that's why I ended up with different color primer on the jet. It's actually K36, me experimenting with tinting stuff. That's how I ended up different colors. It wasn't a pre-thought out thing. I want to do a gray camo. No. That was an accident. Okay. There's still a lot to do even when you're ready. You think you're ready to fly the airplane. The taxi test is really the delineation between it's a project versus an airplane. When you start moving under its own power, it's an airplane. At that point, you can go fly. Question is, are you ready? That's when I blew up the engine. Okay. So remember I said we modified the engine, took the PTU section off. I'll show you a picture later of why that happened. Okay. Just because you have a good idea you think you have a good idea doesn't mean it's a good idea. Remember, building the airplane, any custom built airplane is an evolution. You have to be open to change. All right, this is that primer I was telling you about, the K36, the one on the left, different colors. Just me playing with doing different colors. That's all that is. Okay? And in the process, you notice the primer looks shiny. I figured out how to do that, how to make primer look shiny. It's kind of cool. It's a real easy trick. The top right is before the prime. The bottom right is after. That is a big deal when you get the airplane all one color. It makes you feel so much better, and the airplane looks so different once you get it all one color. Top left, sand and fill, sand and fill, sand and fill. Rutan, I'd read a long time ago, said it's easier just to put the whole thing in micro, sand off what you don't want. I have to agree. There are people that would argue with me. That's how I do it. It's easier to fill the whole thing where you know the low spots are, and then sand off what you don't want. The bottom left picture, you could see. You sand off what you don't want. You can see where the different areas are, the wing, where the spar is, down through the center of the wing. Bottom right, that's what you end up with. Just keep sanding, keep after it, don't stop. Okay, blew up the engine. In the top left picture, see those big tubes going from the PTU section forward? Those are actually tubes off of bleed air that cool the PTU section. Okay, great. Well, we took the PTU section off, right? Don't need it. So I don't need those tubes, right? Nope. So we plugged those holes. Look at the picture on the top right, or on the right side. See that nice bright silver square about 3/4 of the way up to the right of that guy's hand? That's Mike's hand. There's one right next to his hand. There's one further around to the right. That's where those tubes used to be. What we learned later is this engine is incredibly balanced inside with airflow. By plugging those tubes, I unbalanced the airflow inside the engine. And that allowed or forced air over the number 2 bearing. That air blowing over the number 2 bearing deflected the oil stream. In the bottom left picture is what's left of the seals that were around the number 2 bearing when the number 2 bearing seized. I was on the ground naturally doing taxi tests, caused a compressor stall, tires squealing, people screaming, cats and dogs making love. It was real horrible. It's just incredible bang, sound, screech, and it doesn't sound good. So the forensics, we figured out that's what had happened. We also went to a guy by the name of Tim Arfons. He's an expert with this kind of engine, and said, whoa, what? And all he said was, those have to be uncovered. That's like E.F. Hutton. You got to listen. But Tim was nice enough to sell me a replacement bearing and the seals and all that at a smoking nice price. So we were able to rebuild the engine. That only took a year to do all that, to tear it down, because to tear it down takes some rather extensive, very custom parts. Okay, so it's not a simple, easy process by any stretch of the imagination. The top left picture is a part of the electrical system. That's what's known as a power board. Blue Mountain Avionics, Greg Richter built that just for this jet. Everything in the airplane goes through that power board. Okay, so it's one point connect, so to speak. All right, didn't quite work that way, because power board needs to either be 12 or 24, and since half the systems are 12, the other 24, couldn't get the batteries to charge right, so we ended up taking the entire airplane to 24 volts, and then the bottom right picture is where the stuff that needed to be 12 volts, I tapped off of it through transformers to 12 volts to make everything happen. The big black thing in the bottom right picture, that's the hydraulic nose lift. Okay, there's normally a cover over that. You can't see it, seals up the air. And the hole that you see on the bottom right picture on the left side, or on the top right picture on the right side, that's where my fire extinguisher goes. Remember I said that I had a problem with the weight and balance? Ended up having to put 4 batteries in the nose, 4 12-volt batteries. And I wanted the fire extinguisher anyway, so it's kind of cool, 18-pound fire extinguisher up front. Those lines go to the engine, all the way back to the engine. I needed that weight to get the weight and balance where it needed to be, which is cool because that gave me functional weight instead of just putting lead in the nose. So now I had the 4 batteries. I could self-start anywhere. I've done it many times. I don't need a ground power cart to start this airplane anywhere. I've done it many times just off the batteries, and they don't even burp. It's amazing how much power those 4 batteries have. And then a fire extinguisher system, fortunately, I've never had to use it. I got it from Firefight 1 in Orlando. They custom built the bottle for me just for this purpose. First flight was in 2017, February. People want to make a big deal about first flights. Yeah, it was an accomplishment. There's no question. But at the same time, it was not dramatic. It's a very deliberate act. Everybody on the team is incredibly focused. There's no thrills, no excitement, no high fives, none of that stuff. It's a very closed support group, deliberate in what you're doing. It wasn't, oh my God, it's flying. No, we knew when the first flight was going to happen. You have a very programmed test flight program. And you, once again, you surround yourself with all the people that you respect and people smarter than you and figure everything out. Who has a go, no go, who can say we're not doing this, I'm uncomfortable, what about this, what about that? So the first flight just really says we did it right. All these pictures are in the first flight. Okay, the top left, Richard Zadow flew chase on me. Don't ever let that guy get guns in an airplane and come after you. Man, he was all over me. Every time I looked up, he was there, close. The right side is the landing. The bottom right is all the guys that were involved. From the left is, that's Robert Harris, Richard Zadow. He was flying chase. Robert's a lot of the brains behind this. You got Mike Yancey standing there in the blue, the dark blue in the front. Master fabricator, welder, can build anything you want. Hand him a hunk of metal, say I want this, he can build it. It's not a problem. I'm sitting in the seat. Terry Sweat is the tall guy in the blue and black on the other side of the airplane. He's the electronics guru. He built, I think, 9 different circuit cards in this airplane to make a lot of the electronics do what I wanted to do. The bottom left, the reason I'm smiling isn't because of the first flight. I was smiling because of the animated way Richard came running up to make that picture. It just, to see that kind of professional individual do what he was doing was quite amazing. The airplane has been, from day one, it's been about education. I like to learn. Unfortunately for me, I learned a lot more than I ever wanted to, especially about jet engines, how they work, how to rebuild them, composite structure, how to figure stuff out for load bearing, the aerodynamics. I used books from the 60s and 70s. You know, air molecules haven't changed what they do since then. So that's where a lot of the aerodynamics came from. It still works. The math that I've had to learn because of the volume computations, the painting techniques, like I already said about the airbrushing, electrical system, I learned more about electrons than I ever want to know. The relationship with the FAA, yeah. When you do something really different like this, you can run up against a lot of roadblocks. It was difficult. You just have to keep plugging at it and to get to where you want to go. The difficulties during construction, like I said, I cannot overemphasize. Just keep going. Don't stop. One foot in front of the other. Took it to Oshkosh this year. Its first real public debuting. It really was its first public debuting. I've heard the stories. I've read the stories. You've read them too about all the volunteers and how great they are and all that good stuff. Let me tell you, it's true. I was shocked. When I first pulled up in the jet, I said, hey, I want to park under Proteus. They got on the radio, went down there, talked to them. Do you have a reservation? Nope, it's that. You know, they actually tried to get me under Proteus and said, okay, well, we could put you right here. Okay, fine. They said, tell you what, how'd you like to be at the Brown Arch? Sure. So the next morning, they came down with a bunch of volunteers and pushed us over to the arch. So there we are, front row, most photographed spot at Oshkosh for the entire show. Okay, I had a 6 a.m. photo flight. I needed help getting the airplane out, and I asked the volunteers, can they be here? They don't show up till 6:30. 20 of them showed up at 6 in the morning to push this airplane out so we could go do the photo mission. The help from the EAA people was just phenomenal. Also, we weren't sure whether we were going to have problems because I've been running the battery so much if we need a ground power cart. Hey, we need a ground power cart. Do what? They actually went and found one that would start a 747 and had it down there ready to go. We could use it, no problem. Just the support It was just phenomenal. I know you're going to have questions. These guys are the ones responsible. It's Steve Braley on the left. He's the engine expert. Mike Yancey next to him. Robert in the middle. Richard Zadow, and me on the right. Okay. You can go to jetguys.co. If you don't get your questions answered here, go there, leave the question. One of us will get it, so we can get it. Without these guys, this airplane would not have happened. There's no doubt about it. And the whole time during the construction, it wasn't we can't do this or we can't do that. It was how do we do this? How do we do that? Through the entire process. And I suggest you take the same attitude. Don't say I can't do this or I can't do that. Figure out how to make it happen. There's always a way. Some of the resources, you can go to YouTube, look up Jet Guys, Facebook, same thing. There's all kinds of videos, like 50 videos on YouTube of this jet and John Albritton's. John's one with twin tail, mine, so you see what it looks like. There's videos with it taxiing with the cowling off, so you can see it working without the cowling, with the cowling, in between. There's all kinds of different stuff out there for you to look at. So what kind of questions do we have?
Sweet, cool, great presentation. Hey, first one here from Bruce. Do you need a type rating since the aircraft is turbojet to fly it?
That's a really good question. If you read through the regs, it can get really confusing. But the bottom line is no, you don't. All you need is a private pilot license to fly this airplane and an endorsement from a CFI. That's all you need to fly this airplane, because it's listed in the operation specifications for this airplane that's all you need. So no, you do not need an LOA, don't need a type rating, even though it's a turbojet. You don't need it.
Cool. David's wondering, is it pressurized?
Only what's in between years. No, it is not pressurized at all. So very good question, though. How do I get up in altitude? You know, you got to go up in altitude to get the fuel burned down. I never did answer that question. So yeah, on takeoff, I'm burning 100 gallons an hour. You get up 17.5, doing 300 knots, you're down to 31 gallons an hour. Okay. So as you go up in altitude, the engine burns less fuel. Well, it's kind of hard to breathe up there. So I have a full-blown F-16 oxygen system in this airplane. Diluter demand, mass, the whole 9 yards, the whole shooting match. So it'll climb so fast it actually hurts my ears. So you gotta it'll go up and down the same speed. It'll go up at 4,000 feet a minute. It'll come down at 7,000 feet a minute. So no, it's not pressurized. So yeah, that can be a bit of a bugger.
Nicholas says, awesome build. Would you do it again? ? And what would you do differently ?
Yes, I would do it again in a heartbeat. There's no question about it. Build another one, just like it, only better. I'd make it simpler. I would take out some of the snarky, complex stuff that I've put in it and build it simpler. The power board would not be there. I'd be using regular switches. I'd make the electrical system 10 times more simple. So it makes it easier to work on, makes it easier to build, easier to troubleshoot, the whole 9 yards. But yeah, oh yeah, definitely. And it wouldn't take near as long to build it because I know how.
Cool. Cameron's wondering, did you cut out the ailerons before glassing the wings in order to do them in carbon?
No. You glass the entire wing except where the ailerons are going to be, because you know where they're going to be. So you've got a black felt tip marker there, and then you use a die grinder or a fine saw is what I used with the blade, and you cut out the glass where your aileron's going to be, and then you lay the carbon on top of the foam, and then cut that out, cut the ailerons out after that. So it's all one piece when you start.
And Jared's wondering, how did you decide to use carbon fiber versus fiberglass in certain parts of the aircraft?
Came down to strength. The ailerons, I wanted the lightweight and the strength. And in the cowling, it's 100% the weight. That same cowling made out of regular carbon or regular fiberglass would probably go 25, 30 pounds easy. to get the same amount of strength that I have for the size that it is. Now, the canard tips, the winglet tips, elevators, and ailerons and cowling are the only thing on it that's carbon. Everything else is regular fiberglass. And that's part of it was because of the cost. At the time, military was snatching up all the carbon, and it was $75 a yard. So no. But that's how I came up with the carbon idea, or why to use the carbon in just those areas.
Robert's wondering if you could name just a couple of your good engineering reference books that would help him with aerodynamic design and intake plenum design, also structural analysis.
Yeah, no. I mean, and I don't. If you email me, I will find those references. I have the book sitting on the shelf. I meant to look before I started doing this webinar and get the names because I knew this was going to come up. It is, like I said, there are no secrets, and I can I'll get all those names to you. It's not a problem. Author and title of the book.
So Mark, a couple other people also were kind of wondering, what's your range, what's your fuel capacity, and what's your cruise fuel burn?
Yeah, I left out a lot of that stuff, didn't I? That was by accident. Got sidetracked to some other stuff. The inboard pods are fuel. The outboard pods are baggage. Okay. The inboard pods hold about 20, 25 gallons apiece. The strakes hold 107 gallons. Okay. So about 160 gallons right in there is what's in the airplane. So at 31 gallons an hour, do the math. Figure 40 gallons for the first hour, 31 gallons an hour thereafter. It's an easy 4 hours at 300 knots. So you're covering 1,200 miles. Now I've got a 2-hour bladder. So it's rare that I have that much fuel in the airplane. Usually I only have about 80 gallons in it and go out and fly around for an hour or so and come back. But if you really want to go somewhere, yeah, 4 hours, no problem.
And service ceiling, Mike's wondering?
Yeah, it's a mechanical fuel control, and it's designed for a helicopter. Helicopters don't go that high, right? So what you run into is once you get up to about 17 or anything above 18,000 feet, the fuel controller starts freaking out. It doesn't know what to do. So it's not used to going at it. It doesn't have the math or ability to go above that altitude. So it just starts dumping in more and more and more fuel. So the higher you go, the more fuel it'll burn. So your fuel burn actually goes up once you go above a certain altitude. So a practical altitude, 17, 18, that's about it. Now, could you go to 25? Yes, but then you start getting RVSM airspace and all that kind of stuff if you go up to those altitudes. Now, that being said, we're working on a digital fuel control, literally, to replace the mechanical fuel control, and it'll fix that problem. So we'll be able to go up higher, and we should have that by summer. We're hoping we'll have that operational.
So the plane continues to evolve.
Oh, definitely. 100%. The whole thing's an evolution.
Tim says, sorry, I missed you at Oshkosh. Are you going to be there again this summer? I guess he means 2018.
Yes, we're going to have my jet. We're planning on having John Albritton's, and the Cozy Jet should also be there. Should have 3 of us there, and they've already told us they want us. They didn't give us a choice, actually. The EAA told us we're parking at the Brown Arch. We went, okay. So we should be coming in the 3 ship together. We'll be noisy. That's our job. And we should be parking at the arch again.
That'll be something very cool. Wow, that'll be neat. Hey, Paul's wondering, any kit or plans in the works?
Not a bit. Not one. Because this is a one-off airplane. The kit requires an enormous amount, in order to do it right, enormous amount of builder support. And that's not something that Robert's interested in. I'm not interested in because I want to move on to other airplanes. Like I said, I've got a Long Easy that's going to be heavily modified as a 2-place trainer. So to teach people how to fly canard airplanes and check them out in canard airplanes. So I already have other projects I want to go on to. Robert has other projects that he wants to go on to. So no, there's no kit going to be involved at all. Now, if you want one of these, you could go to Robert and say, I want one. He's going to go, what's in your wallet?
John's wondering, will you also be at Sun and Fun?
Yes, the intent is I will be at Sun and Fun with this. And
Okay.
I'll be parking with the rest of the Canard airplanes.
And David's wondering, what's your landing speed, runway distance needed?
Yeah, very good question. I forget all this stuff. It's so common to me. I'm so used to the airplane. I forget that people want to know this stuff. It flies like a long easy. Okay, that was one of the design goals in the airplane, was it has to be really, really easy to fly. I'm too old to work hard flying an airplane. Okay, so, and I'm almost 60. So we wanted it really easy to fly. We got that. It flies just like a long easy. With the difference is it comes off the ground at about 80 knots, heavily loaded. Okay, but once you're pointed up, it goes where you're pointed. So if you got a 10-degree nose-up attitude, it's climbing at 10 degrees. It's not plowing through the air. You're booking 4,000 feet a minute. Coming in on final, I shoot for 90 knots on base, 80 knots on final. When I cross the fence, I don't want to be faster than 75. If you're faster than 75, when you try to land, the thing just skips down the runway. It doesn't want to quit flying. So it's very docile. Unless you get way up there in the speed past where I cruise at, it's a very docile airplane. There's no nasty habits with it at all that I've been able to find.
Cool. Hey, Joe's wondering, how do you avoid FOD damage, and especially at Sun and Fun with all that sandy soil?
Yeah, if you put a stick on the ground or something on the ground underneath the intake of this, it won't suck it up. It's really kind of cool. There's the airflow going into the intake is rather substantial. There's no question about it. But I've yet to be able to move anything on the ground. Now, the only time I move stuff is underneath the tailpipe. But as far as intake, I've had zero problem with trying to move anything. And we've actually put stuff under it before, or stuff's blown under it, grass and that kind of thing. And it doesn't, as a matter of fact, I taxied out at Oshkosh off the grass.
And let's see, Boonan's wondering, are there speed brakes?
Nope, no speed brakes. Kind of, sort of, yes. Actual functional deliberate speed brakes, no. You could step on standard long easy, you step on both rudder pedals. It loses about a knot a second to slow down. If you just step on both rudder pedals, because both rudders go out, it's kind of, small speed brakes. So there's no real buffeting. You could feel the pressure on the rudder pedal, but there's no buffeting associated with it. And the nose gear, if you look at it from the front, sometime it's really, really wide, the fairing that I put on it. That's intentional to give me the drag so that I can have our engine RPM up on final. So if you really want to slow down, just, the gear is not up or down. I could stop it anywhere in between. So if you're in a real big hurry to come down, just step on both rudder pedals and pop the gear out about 3 or 4 inches. You're coming down. I mean, even without doing that, I come down 7,000 feet a minute. If I just stuff the nose over and hold 200 knots, it comes down to 7,000 feet a minute.
Doesn't that hurt? I mean, how can you do that?
On the ears, yeah.
Yeah.
Yeah, you blow your nose a lot. Pop your ears a lot, trying to catch up.
Yeah.
You kind of get used to it, but you feel it.
Hey, James is wondering, how did you solve the weight and balance problem after you first mounted the engine?
Yeah, that was the engine was too far aft, and we did an initial weight and balance with the airplane relatively empty. Didn't have all the systems in it yet, didn't have all the stuff in it, but we went ahead and swung a weight and balance on it. And that's where we found out it was ridiculous tail heavy and how much weight I was going to have up front. I forget the exact number, or I would tell you, but that's where we figured out that I needed, it ended up being the weight of 2 batteries and the 18-pound fire extinguisher up front. I knew I wanted a fire extinguisher, and I knew it weighed 18 pounds, but I didn't know where I was going to put it yet. That kind of determined where I was going to put it. And it ended up by putting the 2 extra batteries up front and the extinguisher. It's exactly in the center of where it needs to be for a zero fuel center of gravity. It's perfect.
Sweet. A couple more people were wondering, I think you mentioned it, but if you could, again, the pods hanging off the wing, I think you got 4 pods. What's in those?
Inboard is fuel. They hold about 20, 25 gallons in the inboards. It's it varies with temperature. The hotter it is, less fuel, colder, more fuel. But the outboards are strictly baggage. The back end of the outboard pods comes off, and it gives you a tube that's 1 foot in diameter and 5 feet long. So you can put a lot of stuff in there, and they're all permanently attached to the strake. So, and I've also obviously reinforced them for the fuel, because fuel weighs more, and the baggage pods are reinforced also. So I could carry a lot more weight than the stock pods only carry 15 pounds that you find on a Long Easy. That's all that's supposed to be in them. Well, mine are permanently attached and reinforced, so you could fill them up, put whatever you want in there.
Yeah. Hey, we're getting close. Looks like we got about 4 more minutes. Let's get a couple more questions. David's wondering, did you use expanded foam in the fuel tanks?
No, not at all. The expanded foam, I found, the problem I found with expanding foam is as it ages, it contracts. And that caused me some problems with a couple things I built. I ended up throwing them away. So I try not to use expanding foam. The strakes are built pretty much conventional, like a Long Easy, except they're a lot bigger. And there's a lot of internal structure in the strakes to support the weight of the fuel pods and the baggage pod. So there's actually a subspar in the strake, plus all the fuel baffles for that much fuel in each one. It's 1 foot deep in the middle. It may not look like it, but it's 1 foot deep. So it's regular, is it Divinycell foam? That's all it is, bent. You just heat it up and bend it to the shape you want.
Todd says, you said you changed airfoils. What airfoils did you use for the wing and canard?
The canard is a stock GU canard. That's the outside shape. Okay, so the inside, the construction is different than a GU canard, but the airfoil shape is a GU canard. The main wing is an E-racer wing, and E-racer center section heavily modified. The center section is heavily modified. The wing's internal structure is heavily modified. So the airfoils are E-racer and GU canard.
Okay. Mark's wondering, did you do stall tests?
It doesn't stall. It just does a pitch buck, and the answer is yes. 68 knots, I start getting pitch buck.
And Bruce is wondering, will the aircraft adhere to noise restrictions?
Yeah, it makes a lot of noise. It's no, being a experimental airplane, you are not restricted by the noise restrictions that airports have, stage 3 noise and all that kind of good stuff. Because in an experimental airplane, you could put any engine on it what you want. I could put a Lear 25 engine on this and go fly around all I want, and nobody could say a word. Now, do I make a lot of noise? Only in certain places, because I am still cognizant of trying to be, friendly with the neighbors and that kind of stuff. But there's no legal restriction.
Gotcha. Some nice comments. Mark says, wow, really worth checking out the Jet Guys on YouTube site.
Yep.
And Frank says, what an interesting project and story. Thank you for sharing.
Yeah, that's one of the things I wanted to, the thing is education. That's what this whole thing's supposed to be about. And it's to take out a lot of the mystery. There are no secrets. There's a lot of mystery about the jet engines. It's just a power plant. It just makes the thing go. Get rid of the mystery. Figure it out. Learn how to do it. I mean, don't take anybody saying, "Oh, it's a secret." No, it's not. Yeah.
Yeah. So anyways, kudos to you, Rich says, and thank you so much for sharing this with us. Please take a moment, just share your closing comments with, we had probably 220 people logged in tonight interested in your presentation.
Cool. That's good. Well, I'm glad they did log in, because that's it shows the interest is there, and also hopefully some people can get motivated by seeing this.
Right on. That's a beautiful thing about EAA, is sharing information with each other, motivating each other, helping each other. It's all about sharing information. So thank you
Exactly.
for sharing your information tonight. It was awesome. Congratulations to you and your entire team of people who had their hand and mind in combining with your hands and putting together that beautiful aircraft. It looks good too, and it's quite something to behold. Congratulations.
Yeah, it's daunting. We're so used to it now. I busted the chops of the guys out there. I had to start it up because I hadn't started it in a month and a half, and fired it up, and nobody came out. I went in and said, "What is this? This thing's normal now? Nobody even comes out to look." Because it's commonplace with us. We forget just how big a deal it is. So it's kind of cool to hear it, but to us, it's another day. What's next?
Well, good luck with your next project. That's a great goal, to make yourself available to give training, so people understand canard type flying and can get dual flight training. Thank you for doing that. That's so important for our community to have CFIs out there doing that in experimental aircraft.
Definitely. It's so easy. Just, it's one of the things that used to irk me, still does. People go out and try to learn stuff on their own when there's so many experts, I mean, real, true experts around to teach you how to do something. Why go teach yourself? Learn from somebody, take the risk out of it. So that's part of what the two-place trainer is all about, is a very programmed, methodical way of teaching you how to fly this airplane, or any canard airplane. It'll work for any, and just have a nice, safe environment. And that's part of what, to me, EAA is about, promoting a safe environment.
Awesome. Lance Hooley, thank you so much for sharing your information. And for everyone who tuned in tonight, thank you so much for joining us. Hope you can join us next week when Gordon Penner is going to be talking about stall spin awareness. Good subject. Have a great night, everybody. Thanks for tuning in.